This work is about learning UI selection criteria to improve the crawling of linked open data. The web of linked data is growing fast. But now billions of archive triples available to the linked data web, covering many domains such as health, agriculture, music, and so on. The design objective of linked data crawler is to fetch linked archive data as much as possible while minimizing the download of irrelevant UIs. the UIs leading to resources without RDF content. A challenge to linked data crawlers is to determine the RDF relevance of UI without downloading it. Here, the RDF relevance means the representation of the UI contains RDF data. The problem is crucial to the throughput and coverage of linked data crawling. Existing work uses some heuristic rules to identify RDF relevant UIs. In real cases, it hurts the coverage of the crawling because there are some hard UIs whose RDF relevance cannot be determined by the heuristic rules. So in this work, we build an online prediction model to predict the RDF relevance of UIs. More specifically, given a UI UT discovered from the RDF graph G obtained by dereferencing a UI UR, the core task of this work is to build a learning model to predict whether UT is RDF relevant or not. For feature selection, we identify four sets of features for the prediction task. The first group of features come from the UI information and HTTP header information of target UI UT. The UI information includes some information like the host information, parse information, and port information, and so on. The second set of features come from the UI information of referring UI UR. The third set of features come from the UI information of direct properties which connect UR UT in RDF graph G. And the last group of features come from the UI information and similarity information and relevance features of the sibling UIs of UT in graph G. In the next step, the features of target UI UT are transformed to a feature vector by a non-cryptography hash function. Then, given a sequence of UI, we predict the RDF relevance by computing probability PT, which is the output of sigmoid function. The input to sigmoid function is the product of two vectors, the feature vector xt and the weight vector wt. So based on the FTIL proximate algorithm, which is the online learning algorithm, the updated formula for matrix W in round t plus 1 is like this. And we can see that it considers some factors like subgradient approximation, stabilization penalty, and L1 penalty. So basically, we use this way for the prediction task. And for evaluation, we first evaluate the predictive ability of a different combination of feature sets. We found that the feature combination of all feature sets without the sibling feature set got the best performance. And we also found that the feature sets from target UI UT are important to the prediction task. And in the next experiment, we implemented a crawler with online prediction component. We show that the crawler doubled the performance of other crawlers with a static classifier in terms of percentage of retrieved RDF relevant UIs. Thank you.